as we speak. Okay, so you guys can take it away.
Okay, very cool. Nice to meet everyone. Thanks for introducing yourselves. I'm gonna share my screen. Did that work?
Yep.
Very cool. Is it full screen? Can you see? Okay, nice. So I'm Russ. Santiago's on the call as well. We're both mechanical engineers from Naval Surface Warfare Center, Philadelphia Division. We both are about 3 years out of college, where our first jobs out of college are working here. And we've been mentoring FIRST Robotics since we started, pretty much. I first started going to Central a little bit on and off with Sean Gallagher. And we went to Edison for 1 year. And then I went to Bodine for 1 year. And then now I am mentoring U School virtually. And I'm not the best at FIRST Robotics personally. I think Santiago is kind of the same. We just try to provide like professional experience or insight or problem solving techniques. And I will say that I'm like blown away every year. Even though I've been doing this for 3 years, you all know so much more about robots and all that than I do. So congratulations. But yeah, so also Santiago he just left the Navy and he is now starting a job with NASA, which is pretty cool. All right, I'm gonna start. So I was born and went to high school in Bucks County, PA, north of Philadelphia. In high school, I knew that I liked science and math. I didn't really know exactly what I wanted to do. I tended to be better at science and math than other subjects, and I was advised to look into engineering. So I did, and then I looked around and I chose Penn State because I wanted a nice big school. They have a lot of opportunities and funding for labs. So I went to Penn State for mechanical engineering. And I didn't really know which engineering I wanted to go to. I kind of just fell into mechanical engineering. And then when I was there, I was like, this is good enough, I guess. And stayed with it. And I'm happy that I did. And then through college, I did an internship at a steel mill near Chicago for summer, and we worked on maintenance, and it was big machinery, and it was kind of like what's in the picture. I kind of just picked a stock photo, but and that was a great experience. And then after college, like I said, I am at Naval Surface Warfare Center, which is an organization within the Navy.
Okay, so like Russ mentioned, my name is Santiago. I'm from Miami, Florida. I went to Florida International University in Miami. It's also a larger school. One thing that I wanted to point out, kind of like Russ, I wasn't entirely sure what I wanted to do when I started college. And it's okay. I want to emphasize to you guys that it's okay. You do have a little bit of time to kind of figure out what it is that you want to do. I also enjoyed science and math. But I did switch majors around a couple times. I think I was a math major at first and I switched to physics. And then I ended up settling into mechanical engineering. In my later years, I performed a lot of research for 2 labs, most of it focusing on HAL aircraft. They're called flying wings. They're essentially big drones, kind of like the one shown there, and wind turbines. So that was some of the research that I did. My background was in aerospace for the most part. My electives were aerospace classes as an undergrad.
So as mechanical engineering majors in college, we studied, like we said, math and science were big coming into it. And once you start, those are the first classes you really do. And they're kind of the core foundation for the rest of the engineering classes, specifically physics and math. Then when you get into the major, across colleges, at least from where I can see, a lot of the colleges are very similar. When you do mechanical engineering, they're going to go over physics and math as your base, and then you're going to get into heat transfer, thermodynamics, fluid dynamics, and stuff like material science is very common. So heat transfer and thermodynamics is just the study of where heat moves. Fluid dynamics is like the study of the airfoil on a wing, how the air flows or how water flows. And then material science, like shown in the picture, it's a lot of testing and seeing results of what materials are strongest for which situations and which have the strongest tensile strength. And then we use all that information to help us design.
So we work on a variety of different projects for the Navy. Again, one of the misconceptions that I had when I was an undergrad was that I thought that when I graduated, I was going to be designing these gigantic things and that it was going to be not necessarily a teamwork thing, and I was very mistaken when it comes to that. Both Russ and I work in very large teams of multidisciplinary engineers. So we work with electrical engineers, computer engineers, computer scientists, and typically you focus on smaller components of bigger systems. So some of the larger systems that we work with are lasers, rail guns, radar systems, concept designs of future ships. One of the biggest things that we're focusing on in the Navy at the moment is electric ships for future designs, and then smaller component level things like heat exchangers and batteries and HVAC systems.
Yeah. Also, to go back to this one, I want to note that at least for where we are, a lot of times mechanical engineering covers a pretty broad array of specific fields, and when you come out, you kind of end up focusing, or within college, you focus your career. So right now, I'm focusing it on heat transfer and thermodynamics, whereas Santiago is focusing more on fluid dynamics. Is that right?
Yeah, I do mostly fluid dynamics and a little bit of heat transfer.
So I personally, in my day-to-day, I work, like I said, on thermal systems. And I am in the research and development division, so is Santiago, but I focus on a lot of writing models in MATLAB and Microsoft Excel VBA that just are to model a physical system, what's going to happen under different situations. And then we use those to run simulations to predict the performance of a system, either to gauge how a future design might look, or how an old system, if we add in this new component, will change. And then my other big thing I've done before the pandemic was running physical tests on a physical test site where we work, which I liked a lot. And that was testing different types of refrigerants and different components that go into that system. And then on some other stuff I've done is working in CAD to design parts or assemblies. I've also gone on ships and done ship checks, which we don't do a ton of in R&D, but most of our organization, as far as the technical side, does a lot of that, visiting ships and checking on systems.
So like Russ said, we're both in our R&D needs research and development. We're not in the same code, but we work in very similar projects. And in fact, Russ and I have worked before in the same projects. One of the things that you try to do as engineers is you attempt to model how the physical world works with simulations and mathematical models. Like Russ said, to try to understand how things work. If you make changes to them, if you make predictions on how future performance is going to be, then you can make changes and save money when it comes to creating physical models. And then there's obviously a whole array of steps that you can take to validate those models. Most of the models that I make are computational fluid dynamics, which is CFD, um, as well as thermal and electrical models. Like I said, I have worked with battery designs before, and part of that work involves understanding the thermal performance of different batteries when they're being charged and discharged, and how we can make sure to, dissipate that heat, prevent failure, overcharging, things like that. Another big part of what I do is cooling systems. So, for example, one of the projects that I'm working on at the moment is we're designing a cooling system for some submarines in Pearl Harbor in Hawaii. And what that entails is essentially you see uh, the ship as a heat load, just a number of an amount of heat that has to be rejected, and you kind of figure out how to make a system that will provide enough water at a certain velocity, that will reject enough heat for the system to not fail. So I also work in SolidWorks, making assemblies. Um, in order to perform those simulations, whether they be in CFD, like the picture in front, or in simple mathematical models, also in Excel, and sometimes MATLAB, definitely not as much as Rust, um, uh, using the equations you see on the right. So the reason why I included that equation is because it is not very complicated, I think, but it is very important. It is definitely one of the ones that I use the most at work. And it is simply an equivalence of different types of energy. So energy from pressure, kinetic energy, which is essentially energy at motion, and potential energy, which is essentially the energy you get from having a mass at a certain height. And it's essentially one of the equations that I use the most to create the physics-based models that I do in Excel and in MATLAB. So that's I felt it necessary to include it there because we do a lot of math, like Russ said.
Yeah, I want to also, Santiago was saying like the kind of application of what we work on. Like sometimes our projects can be a little boring sounding where they're making a model of something in Excel, but the application is usually pretty big. It's like cutting edge stuff where they're trying to put laser weapons on ships or railguns on ships or these brand new radars that are take this insane amount of electricity and they can't physically handle it on ships. And for me, a lot of it is application of the cooling side. So we're doing testing to see if it's even feasible to put a laser on the ship with this specific cooling system. Otherwise, if it doesn't work, it's just going to melt down and then break. And it's like billions of dollars down the drain. Yeah. Okay, really basically, like I said, we work for Naval Surface Warfare Center, Philadelphia Division in the Navy Yard. It's in the bottom of Philly, we're by the stadiums.
So the U.S. Navy is encompassing of a lot of different divisions, not just the surface warfare centers. So I don't know if you guys know, but for example, the Marine Corps is under the Navy, and it's something that we work with very closely in a variety of projects. Along with the surface warfare centers, there are underwater warfare centers that essentially work with submarines. There's Nav Air. Believe it or not, the Navy has a very large number of fighter planes. So it's definitely not just the Air Force. And there's a lot of naval pilots as well. There's SPAWAR, which deals with space systems, such as satellites, launches, things like that. And there's NAPFAC, which is the facilities part of the Navy. So they deal with maintenance of ships and of different facilities as well that we work for. I believe those are the main ones, but I just kind of wanted to emphasize that we don't just work on ships. There is definitely a variety of systems that the Navy works with.
And we specifically, where we work, focuses on all the engineering required for all below deck ship systems. So I'm gonna ask for some participation from you. If you want to unmute yourself, feel free to answer. What systems do you think are required to run a ship, or technologies or anything? Just for a ship to run, it needs to be able to run correctly.
Definitely some sort of a thermal and electrical system because everything uses energy, and once it uses energy, it heats up. So you need to dissipate that energy, right? And electrical systems for everything to be connected, and for it to work.
For sure, that's huge.
That's
Both of
absolutely
those
right.
are really big. And on the electrical side, we have like a power plant. It's pretty much like a small town that we have to power because there's all hundreds of people that live on the ship, and then all of the required technologies on there, they take electricity. So we have just huge generators. It's like a power plant in the ship. Anyone else? Any other systems?
I mean, you also have to physically build the stuff too, so that requires engineering. Regarding like material science to know what's the best material for its price for
Mhm.
efficiency sakes.
Yep. Yeah, it's a big structure, so there's a lot of structural engineering goes into it, designing the hull. There's also so communication systems, and then like if you want to be able to see other ships coming or aircraft or missiles, you have to have radar. In order to move the ship, what do you need? You need like, what do you see on ships to move them? They have tires.
Is it by turbines?
Yeah. So they have turbines, but they drive specifically propellers, and that whole system is called propulsion system, and that's massive, huge machinery, a lot of energy to move it. Then there's a lot of energy to steer the ship. So here's a list of some that we work on. We have propulsion, like I said, electrical power. Then we have cooling. Like Brian was saying, cooling is really important because you have this machinery that moves and you're giving electrical power, and that dissipates for the most part into heat. And I don't know exactly what the time is, but there's some known amount of time that if the cooling system goes down, it shuts down all the machinery and then you're dead in the water. Then there's structural, like we said, the whole navigation system that includes radar and communication, and then control systems. You have to, it's just, the ship is millions of systems that are all integrated with each other, and they have to communicate together. So we have a lot of computer scientists that work on that. Part of all behind this is like cybersecurity, right? That's huge.
And one thing that Russ and I thought was important to communicate to you guys as well was is the fact that organizations require a lot of people behind the scenes that are not necessarily just engineers. So NAPC, or Naval Surface Warfare Center, where we work, is for the most part an engineering enterprise. But I would say that the majority of the workforce is probably not engineers, surprisingly enough, and that's probably true for most organizations that do engineering. So some of the career fields that you would be able to see at NSWC are, of course, electrical, chemical, mechanical, and computer engineers. But we also work with a lot of computer science, a computer scientist, with a lot of mathematicians and data scientists. There are also a lot of mechanics and electricians that work with physical systems that we do test on. There are also pipe fitters that deal with the plumbing systems, for example. Some of the cooling systems that I've worked with, I've worked directly with pipe fitters, as well as engineering technicians, and of course, naval architects who design conceptual shifts for future vessels.
And then we also have business analysts, administrative assistants, even we have a team of lawyers and paralegals. We have contract specialists. There's just so much that intertwines. We need people to assist in getting people to do the right thing. Human resource officers, IT specialists, security, it's cybersecurity, physical security, logistics, shipping, accountants, accounting. Since we don't have anything on the slide, Santiago, do you want to talk about what you might be doing with NASA?
Yeah, so like Russ said, I am beginning work at NASA next Tuesday, actually, and I'm kind of excited about it. So like I mentioned before, my background as an undergrad was mostly in aerospace engineering, and space in general is something that I've always been interested by. Like I said, I'm from Miami, and Kennedy Space Center, which is where they perform the majority of the launches, is in Cape Canaveral, which is a couple hours away from me. So, growing up, it was definitely something that I was very cognizant about. It was something that inspired me, and fascinated me, and it was something that I wanted to be a part of. So I had the opportunity to do work for NASA, and specifically, I'm going to be working on payload safety. So obviously, the point of flying the rockets and launching the rockets is to carry a payload, whether that be to the International Space Station, or the moon, the missions to Mars or the moon. The point is that we're trying to get something up there, and whether that be people, or supplies, or robots, or whatever it may be. Um, I'm going to be one of the people working to make sure that they get up there safely, and that we're doing everything we can to avoid any sort of failures. So that's going to be what I'm going to be working on, and I'm actually very excited about the fact that I am going to be working in the command center for the launches. So that's something that I'm also very excited about. And yeah, we thought it was a cool thing to share that. Not only do you, when you begin a job, just know that you don't have to be there forever. There is opportunity to move around and to explore different career fields. And one of the beautiful things about engineering that I'm sure Russ would completely agree with is that, um, especially early on in your career, you have the ability to kind of broaden your horizons, and you don't necessarily have to do one thing forever. There is an opportunity for you to explore many different fields within whatever field you end up choosing, whether it be engineering or not. And that could dictate where you work and the type of work that you do perform. So just know that just because you're on a path, it doesn't mean you have to be on that path forever, and it's kind of never too late to change the path that you're on, or the career field that you're on. So um, yeah, and if anybody has any questions with regards to anything that we talked about, please ask away.
Well, I'll start. What made you choose the Navy?
I don't know. I was in college and I was trying to find jobs, and it was difficult. So I was applying to a bunch of places, and then I applied down here, and their postings were super vague. And the request was really vague. And I had an interview lined up at the same time for another job. And I was like, oh, I'm not interviewing with them. Their posting is boring. And then someone convinced me to try to schedule them so I could move them around. And I'm so glad I did, because I came down here, and then, yeah, the Navy is great because you're a federal employee. So you get all these great benefits from having, like, they're not going to overwork you unless they pay you overtime. They don't really want to pay you overtime. And then they have very flexible hours. It's huge. So you have tons of opportunities to move around, and they have great programs for, like, if you wanted to go to grad school, they could pay for it, or they have, like, leadership programs you can join. And I like the people, and I really like the location, being in Philadelphia like that. So, Santi?
For me, it was actually a very interesting journey. So I was pretty set on going to graduate school when I finished my undergraduate career. Like I said, I did a lot of research. So kind of just the next logical step is to go to grad school. And my undergraduate research advisor actually not convinced, but he told me it would be a good idea to kind of look around for jobs just to make sure that is something you want, something you want to go through with. And when I got the offer from the Navy, um, I was aware that it was a research and development position. So how I saw it in my eyes, I was basically performing research like I wanted to do in graduate school, except I was getting paid for it. Um, and I, had the opportunity to work with pretty cool systems that we work with at the moment. And like Russ said, the federal government has a wide array of benefits that complement the fact that you're doing cool stuff at work that make it absolutely worth it. Uh, I've taken graduate classes through the Navy, and something you're going to start hearing once you graduate college is work-life balance. And basically, what that means is essentially what percentage of your time you're worrying about work, and what percentage of your time you're able to kind of be home and enjoy your life outside of work. And the government is very, very good about that. And that's something that definitely drove me to work for the Navy, and then continue on to NASA as opposed to the private sector. And I'm pretty sure that's the case for us as well.
Yeah, I do want to, like you said, I forgot about that. The work is interesting too, just the systems that we work on.
Well, how does it feel to like work for the military? Like normally you wouldn't think I mean, yes, it's logical that a scientist would be in the military or like an engineer be in the military, but it's not what you typically imagine. So how is like a life of like an engineer being in like a part of the military? 'Cause
Um,
most people don't like recognize that that is a possible career path.
yeah, yeah, I didn't know that either. When I was interviewing, I was like, "What? This is a contractor job, right? It's not like actually for the Navy." And they're like, "No, it's for the Navy." And I was like, "All right, whatever you say." And it turns out it's for the Navy. We're all civilians. Everyone that works down there, it's about 3,000 people that work down there. They're all civilians except for one or two people. So uh, I I think it's great, like we were saying, because you get the federal employee look, and you get to see it's from the side of the 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 work from the side that actually it's being applied to. I'm saying in comparison to like if you were to work for Lockheed Martin or Boeing, those are all contracted out, and you end up getting a little bit more specific, and the work is like smaller in scope, and you don't get to see the application of it as much, depending on what you do.
Yeah, so just to elaborate a little bit on that, I don't think people realize how incredibly ridiculously big the defense market is. So there's the defense spending has gotten close to the trillions in recent years, and um, a lot of that goes to supporting the warfighter, which is what we do. So we try to help soldiers be as best prepared and have the best tools that they can to sort of carry out their missions. And it's pretty cool. I think it's pretty cool to be able to say that we do that. And um, it's because we work in research, or at least my personal experience, I haven't been able to go out as much and see the physical ships, and work with actual soldiers or Marines or Navy personnel. But we do understand the importance of our work, and we do understand that the work that we do could potentially save lives, and we take it very seriously for that reason. I mean, yeah, you make a good point. A good point. It's I feel like when I was in school, it wasn't something that I thought of, that you hear about the Army Corps of Engineers, but other than that, I wasn't aware that there were so many opportunities for engineer within the Department of Defense. So.
Where are my other students? Some
Hi,
questions, please.
I have a question. Have y'all ever had like any problems, like a work at the Navy?
Had any
Sorry,
what?
can you repeat that?
Have y'all like ever had like any problems working at the Navy? Have y'all like ever found something to be like difficult or something like that?
Yeah, Santiago, you want to start? I want to see your answer first. Yeah.
I mean, it's
Anyway.
like any other organization. There's
Yeah.
gonna be pros and there's gonna be cons, and it's your job to mitigate the negatives and try to do your best and try to focus on the positives. And um like I said, it's I mean I don't think it would be it would be good for us to focus or talk specifics on some of the issues that we've had, but just like any other large organizations, uh, there is when you have a bunch of people working somewhere, there is going to be a chain of command. So in order for some of the products that Russ and I work on, are millions and millions of dollars. So sometimes when you do need approval to spend that money or to buy certain things or to perform certain work, you need a couple people to sign on it, and it goes through more than a few people. So um, there is a bit of a time consumption aspect to being able to perform certain work, just because so many people have to agree that what you're trying to do is reasonable. But
Mhm.
I don't I don't think that's a government or a Navy specific problem. I just think that's how large organizations are. Um, I don't know, Russ, do you have anything else in mind?
I'm trying to think more on like the specific what's unique about us that could be an issue. It does kind of fall back to that. I mean, like the trope or the stereotype of like the government being a little slow is true, but I kind of hold that to being there's so many people that work for it to end up getting a lot of layers. So like Santiago said, you have to go through a lot of people to complete processes, and then there's a lot of people that work for the government, so a lot of policies are set. From what I think, a lot of policies are set um, to cover a ton of people, where it might not benefit organization, but overall, it's in the best interest of all federal employees, or specifically within the Navy. There's still I don't know how many people work for the Navy, but probably hundreds of thousands, and they have to make a policy that's set across all of them. Whereas as a smaller firm, there might be more agility with that. But personally, for me, all the pros way outweigh the cons for that.
Yeah, by far. Definitely by far.
Like I said, like being flexible and the nice work-life balance is like great. And being a big organization, you can move around and kind of choose the specifics that you work on a little bit. And you have more exposure to a lot of different work too.
And to answer the question on the chat, um, so obviously no, I didn't stay with the Navy forever, seeing how I'm moving. But it wasn't anything because I was unhappy or because there was anything wrong with working for the Navy. I always wanted to work for NASA. Um, and in fact, some of the policies and some of the work culture that I am going to encounter in NASA is going to be very similar in a lot of respects to the one at the Navy. Obviously, I haven't started working there, so I can't tell you exactly what the similarities and differences are. Um, but I was never unhappy. I never felt like, oh, I absolutely have to get out of here type thing. It just so happened that the right opportunity opened itself up to me. And like I said, it's life is long. You have there's a lot of things happen, and you know it, there is a possibility for mobility, and there is a possibility for advancement both within the organization and outside the organization. It's a fact of life that people sometimes move jobs and move locations, and things happen, and it's just It's kind of part of the organization. It's part of like the industry. It's just how it is.
Yeah, you have personal reasons to want to move to Florida. And, I mean, and you love NASA. That's like been your dream. So
Right.
let's both play into it.
I have a question. So, how exactly did you get hired at NASA? Were you recommended? Did you like fill out an application for a position? How did that exactly work?
Okay, so this is a very good question. I'm really glad you asked this. So this is not just for government positions, but jobs in general. So something that I was not aware of whatsoever when I was in college was about internships and recruitment fairs and job fairs and things like that. I did not learn about those until like my junior year. Um, and I know something that I felt as a freshman or as a sophomore in college was that, oh, I don't know anything. Why would anyone want to hire me? And it's absolutely untrue. Companies love to hire younger people just because you can perform multiple internships for them, and then they have multiple years working with you and learning from you, and those internship opportunities can result into a full-time offer when you graduate, as well as just the experience of working while you're in school for internships is just, it's amazing, it's invaluable, and it's something that I wish I would have done more of. Like Russ did an internship, and I'm very envious of that. So props to Russ. But how what I recommend you guys do is look up, when you're in college, look up career fairs or job fairs. So there are some that are going to be internal to whatever school you go to, where companies will come and recruit you, and you essentially make a resume. And again, like, it's, you think, oh, I have nothing to include in here. No, like, believe it or not, you do. Like, just any projects you have working on in high school or in your classes in college, whether they be, your first or second year classes, like, there's stuff that there's things that you can put in your resume, or any volunteer experience, or any clubs that you're in or involved with. This is all things that companies want to see. So the first step is putting yourself out there. When I'm sure Russ can completely agree to this. When I graduated college, I applied to maybe 80 jobs, and I got 3 offers. So it's the law of averages, man.
Yeah, I've seen.
So specifically now, to answer your question specifically to NASA, so all government positions are on USA Jobs. They're advertised on USA Jobs. I think it was definitely the case for me. I don't know if it was the case for Russ, but I got my job at the Navy through a recruitment fair. So I actually, spoke to a gentleman who was a recruiter. Actually, Russ and I had the opportunity to both be recruiters. So it was definitely interesting to see it from the other side. But I got my offer at for the Navy through an interview at a recruitment fair. However, for NASA, I applied through USA Jobs. So you can look up all the internships are there as well, and they have plenty of internships, not just NASA, but all the Navy, the Army. They all have various internship opportunities and scholarship opportunities. Like, if you promise to work for the Navy, they have the scholarship. What's it called, Russ? Do you remember what it's called? Smart. So if you do get selected to be a SMART scholar, they'll pay for you to go to school.
Yeah.
And you just owe them the amount of time that they pay for you to go to school. So there's opportunities like that that are absolutely amazing. I'm sorry, I keep rambling on.
No, that's smart. That's smart's good to bring up, because I've known people that get the SMART scholarship their like first or second year of undergraduate college, which is insane to me, because it's like their college is fully paid for, and then all they have to do is guarantee 3 or 4 years to the Navy after college, which is like amazing, because then it sets you up for a guaranteed job too. I think it benefits you.
Yeah.
But
right, it's amazing, and we have coworkers that have gotten their PhDs paid for.
So one of our captains from the Cheltenham FRC team, I don't know if it was a SMART scholarship or not, but he's getting all of his graduate work paid for through the Navy as an engineer.
Nice.
Yeah, no, absolutely.
Awesome.
It's a thing, and take advantage. Like there's so many resources out there. So it was a little bit hard for me growing up. I'm a first generation college student. My mom couldn't help me, navigate through any of this. So yeah, I had to look up all these things myself. But there's so many resources out there. There's so many things that you can do. That are just incredibly helpful. And to finally answer the question, I've rambled on and off. I'm sorry. I applied through USA Jobs. I've again, the law of averages, like just be a good candidate, keep your head up. Try to apply to positions that are relevant to you and that are interesting to you. I applied to 60 positions at NASA, 60, and I got 2 offers again. So it's not, don't let rejection like bum you out. Don't It's how it is. You know what I mean? A lot of these things are very impersonal, or through online, where computers just reading your resume and making judgments, and just don't let the negatives get you down. Like it's how it is, and keep your head up and it'll be fine. I'm sorry, that was a super long answer. I apologize.
That's good.
Ooh, I have a question. So, like, what kind of professions is like the military heavily or like in need of? Like, what is the high demands of like, and what fields are they looking for? Because like, I like physics a lot, like pure physics. So like, I want to be a physicist. That requires grad school, right? I'm just thinking like, would there be a possibility of a physicist being in high demand for the military?
I don't know. I haven't met anyone that's a physicist, but I could meet people that I didn't know went to school for physics and got hired as something else, maybe like a data scientist or something. I will say high demand seems like right now is always like computer scientists. I mean, we hire a ton of mechanical and electrical engineers, and sometimes those people come in with like aerospace engineering degrees and they get hired as mechanical, or like optical engineering to get hired as mechanical. Um, physics. Santiago, do you have any good insight on that? Like more pure.
Yeah, so like Russ said, the beauty of STEM fields, so science, technology, engineering, and math, is that part of the things that they teach you is they teach you how to think. So companies know that. So just because you're an engineer doesn't mean you're able to perform other duties. Um, we work, like Russ said, we work with people who aren't mechanical engineers that perform mechanical engineer jobs. We work with people who work as mathematicians that aren't pure mathematicians, and that's okay. When it comes to physics, I know NASA hires physicists. I know that for a fact, because I've seen positions open up to physicists. Uh, Other branches of government, I am not sure. I am not entirely sure. But something that you might not think about is government positions. There are a ton of labs uh, that are government sponsored. So Sandia, Lawrence Livermore National Laboratory, the Air Force Research Lab, the Naval Research Lab. There's so many labs out there that do pure research, that hire mathematicians, engineers, physicists that you wouldn't think of as like uh, uh, government positions, but they are. They just, you have to go to grad school, you have to get a PhD, and you have to be a serious researcher. But there definitely are.
I have another question. So like I'm a very curious person. So like, does the Navy allow the flexibility of like just exploring random fields? It's like that's something I enjoy doing, like advently.
Um, I'll say two things on that. The first is that the Navy, like I said, because it's so big, especially up here in Philly, we cover, we have codes that do a lot of different stuff. Even like a 3D printing lab, and we have structural people and people that are focusing on building a test site, so they're project engineers. Um, so they get to, like I would be able to, if I really wanted to, if I found something like, oh, I really want to do electric elevator work, then I can really work hard and get into that group. So that's the first thing, is we can move around. But then second, to like explore new stuff that's not already existing within the organization. At least in our division for R&D, we can pitch for R&D funding. And people like Tristan Wolf, if any of you have met him, he is just like a really hard worker and spends like diligent amount of time looking at new technologies and is interested in it. So every year he would submit for research funding on a topic that interests him. And as long as he can find a way that makes it applicable to work that we deal with, then, and he's like a good writer for research pitches, then he gets the money. Like one of the cool projects he worked on was, or started to work on, was like studying the aerodynamics of whale fins and bird feathers. So he got like this freeze-dried eagle wing mailed to the base, and he got it 3D scanned. And the plan was like to create these crazy things and put them in this wind tunnel that he was working on. And he had funding for that, but he ended up moving jobs. So now he works full-time in STEM stuff. But yeah, that's what, yeah.
This is 100% true, by the way. Like this is a fact. So like Russ said, the beauty of working for such a large organization as NATSE is that there's so many things out there that you can do. We personally know coworkers of ours who have started in one topic and have completely changed positions. We work with a buddy of ours who is an electrical engineer and decided he wanted to do cybersecurity, went to school for cybersecurity, funded by the Navy, and now he works in cybersecurity. So there's opportunities out there, not only through education. I know we focus a lot on grad school just because we work in research. So like it is an important tool, but even service engineers, you know, there is an opportunity to move around and do other things that you're interested in. One of the things that I did when I started was I keep going back to aerospace. So I was very interested in aerospace engineering. So I tried to look for projects that related to aerospace engineering. So I went out and talked to different team leads, talked to different branch heads, talked to different people, made connections. That's very important in any job, in any career field. Talk to people, learn from people, especially when you're a young person. No matter who you speak to, I promise you're going to learn something new. Whether they're in your field or not in your field, there's always things to learn about. So one of the things that I tried to do was to learn about different projects. I would ask to be put in projects that I had no experience in, just so I could learn, just so I could learn new things and see if there are things that I liked or didn't like. And even if you don't like them, that's fine. Now you know there's something out there that you don't like, so you don't ever do it again. So there's definitely that opportunity for us to learn and try different things and move around. And I feel like that's true of a lot of organizations, but it's especially true of the Navy, just because I feel like Russ and I have definitely experienced that firsthand. This whole thing feels like a pitch, like we're just pitching the Navy to you guys.
I mean, I love it. I'm getting my curiosity satisfied.
It's cool, man. It's worth exploring. It's worth thinking about. And like I said, not just engineering. There's so many fields that are so interesting and so cool. And you know, whatever it is that you want to do, we just so happen to be into engineering, and it just so happened to work out for us. But there's so many different fields out there that are interesting and challenging and rewarding and you know, there's jobs for and possibilities to work for.
Do you need to have a master's degree to work at the Navy, or can you have like a bachelor's degree?
You don't need a master's. So I don't have a master's, and Santiago does not have a master's. And we work, even though we actually work in R&D, and I would say like 80% of the people we were hired with at the time, we hired with around 10 people at the same time. Like 80% of us had bachelors and not masters. And across the rest of the organization, I would say a lot of them got hired out of Bachelors.
Oh, okay.
Most of them, yeah.
Yeah, the reason we keep talking about grad school is just because I know Russ and I are definitely curious people, and hey, if your employer pays for you to learn more, like why not take advantage of that? But it's not a must. It's definitely not a must. It's just you can never, like, betting on yourself is always a good idea. So learning more is always a good idea, and it doesn't necessarily have to be technical graduate degrees. A lot of people go into MBAs or systems engineering graduate degrees, which are more, learning how to be a better people manager, learning how to be a better resource manager, or different things. So even within technical fields like engineering, you don't have to be a science guy. You can be a manager or a money guy, or different things, or gal. There's different fields that you
Thank
can
you.
go into. Sorry. Yeah.
Great. Well, it's already 6 o'clock. I don't know if people have places or things they need to do, but I know for me, I thank you guys both really a lot. This has been great. Do you students have anything else that you want to ask, or shall we call it an eve?
So I do have updates on information regarding my team that you might need.